So after my extensive data collection, research, and interviews, here's the answer as to how any sort of ball curves through the air. And it starts with a riddle. Let's say you're an astronaut on the space station and you go out for a spacewalk to fix a solar panel with your big wrench, and as you're heading out you get distracted by the view and miss grabbing the handle, and now you're very slowly drifting away. What do you do to save yourself? The trick is you throw the wrench as fast as possible in the opposite direction, and that will give you just a little push to slowly move you back to the space station. They create a chemical reaction from their fuel to make a lot of tiny wrenches, and they just throw them out of the back really fast, and the rocket naturally has to go the other way, just like you as an astronaut. So that's one thing you need to know, and the other is the Coanda effect, which states that fluids like to curve and flow around a smooth surface. You actually already know this if you've ever noticed how water will flow around a curved spoon. Well, air is also a fluid, and so it curves just like water, as you can see here, because the strings are following with the airflow as it turns the round corner on the frisbee. Okay, so now let's put those two concepts together. From the ball's perspective, air is rushing past on the top side here and curving around really nicely because the rotation of the ball matches great with the airflow. But on the bottom side, they're opposite. So there's sort of a head-on collision with the air rushing by, creating turbulence. That means more air curves around the top, which means more little air wrenches are thrown diagonally down, and as a result, the backspun ball moves diagonally up, just like the astronaut, causing it to curve up. The fancy term for this is the Magnus effect, and big light balls like beach balls are great for demonstrating this effect because they have lots of surface area, so they throw off lots of wrenches, but they're also really light, so the air wrenches have more of an effect. And now that you know this, you know exactly what causes the curve on tennis balls, soccer balls, ping pong balls, record-breaking basketballs, golf balls, and baseballs. With the baseball, the seams help grab even more air wrenches as the ball spins, but they also provide the pitchers a better grip so they can spin the ball even faster. Our normal versus smooth ball test confirmed this when the normal baseball with seams was curving so much more. By the way, this same principle is how frisbees seem to defy gravity, because air curves over the smooth edge, throwing wrenches down all around, turning it into a freaking jetpack.